Hello everyone, welcome back to the new session on image processing. So in the last session we have seen about the edge detection scene, like how we can detect the edge of any images or any objects, right? So in this sessions we are going to do a new topic, that is morphology, right? So I think this term is new for you, right? First let's understand about the morphology, right? What is morphology and how we can apply this one, right? So basically, see, in general terms, morphology means like that deals with the form and structures of animals and plants, right? What will be the structures and of animals or plants, okay? And what will be the form of the animal and plants? That is the normal terms, right? But in mathematical term, we can say image morphology means to extract some components from the images, right? That is, let's take one example. You have one images, right? And inside the images there are different objects, okay? And between two objects there are some gaps, right? So you want to fill that gap. In that case, morphology comes into the pictures, right? So basically morphology is used to to remove some pixels from the images or to add some more pixels to the images. That is called the morphology, right? So basically there are two operations in morphology, right? By default there are different kind of operations in morphology, but we'll focus on these two operations, that is erosion and dilation, because these two are the very important, right? So first let's understand about the erosion. Erosion means like it will shrink the image pixels, or let's say it will remove some pixels from the images, right? So basically what how this will be done, right? Let's suppose you have a you have a kernel, that is the geometrical shapes, okay? As I already told you about the kernel, it's a 2D or 3D, any kind of matrix which is in the form of shapes, right? And you need to apply on each and every pixels of images, right, for different operations. So here what it will do, it will apply it will traverse the structuring element over the images to perform this erosion operations. Basically, let's suppose you are there are two images which is joined like this, and I want to separate these images. So in that case we'll use erosions. So what it will do, it will remove the pixels which is at the end joint of these two fingers, right? That here I'm taking one example, right? So in this case we use erosion. So basically it can use to split any images, two images, joint images, right? Next one is the dilation. Dilation is the reverse of the erosion basically. It expands the image pixels, or you can say it adds the pixels on the object boundaries, right? So basically, like we need to traverse the structuring element, that is kernel, over the image object to perform the dilations operations, right? So basically it is help to like to repair the breaks which is available between the two objects, right? Okay, so let's move to the software and we'll see practically how we can perform this erosion and dilations methods. So first we need to import cv2 module, and let's first read any images. cv2.imread, that is the method. So here I have lots of images. Today I'm going to read different images. Let's suppose here I have, let me check first, like the I want to take some images. Yeah, let's take these images, right? Smarties of png. So smarties dot png, right? After this, what I will do first, what I need to do first, let's check either everything is working or not. So I'll just display this original images, and then let's write down the wait key. As you know, to display your images on the screen you need to write this one, and then destroy all windows, so that when you click on the cancel, everything will be destroyed, right? So if I run this one, yeah, so the image is here, so everything is working fine. Now let's move to the operation. So to apply this erosion and dilation, first what you need to do, you need to convert the images to, you need to apply thresholding, right? As I told you, see threshold, why you need to do the thresholding, because so that you can like first we can like just separate the object from the background. But before that, what I'll do, I'll just convert these images into a grayscale images. So I'll write gray cv2 dot cvt color. This is the method which you need to convert one form of images to the another forms, right? So by default OpenCV read the images in the form of bgr, and we need to convert to the grayscale. So we need to convert with the help of CVD color method. So first I'll take this input images because I want to change these images, and then I'll write CV2 dot color underscore bzr2 gray. Okay, sorry, bzr2 gray. So this is the method, right? After this, I'll apply thresholding. So as you know, thresholding will return you two values. One is the like success, either true or false. Second one is the value. So here, first I have kept underscore empty because I don't want to store true or false. I just want to store the like thresholded value in this variable. You can take any name over here. So first I'll call this method threshold, and I want to apply this threshold on this gray images, and all of you know you have to find out the threshold value. Here I'm taking 150, and then the maximum value of any color is 250. And next one is the methods that you need to write, that is type. So for now here I'm using cv2.thres binary inverse. So you can take any methods, right? Okay, now let's check with first erode method. So here I'll first take a variable erode equal to cv2 dot sorry cv2 dot erode. See, there are two methods, erode and dilute. I already explained you, right? So which we are performing over here. Sorry. Okay, so here you need to pass the first like will be the object on which you want to apply. So I want to apply this erosion on the thresholded images. Second will be the kernel. Kernel, that is the size. Here I am taking, let's suppose 2. It's 2 cross 2 matrix, and third argument will be the like distance, or you can say anchor, right? And for now, let's suppose here, see, this argument is not important. This is like how many times you want to apply these this methods kernels on the images. Let's suppose if you got the output after applying traversing single time, no need to do 2 times. Or maybe like you are not getting the result after first time, so you can apply again 2 times, or still you are not getting the output, again you can apply this third time. Okay, so this is what iteration is. So let's first display these images, and here I just write down erode, and then the value will be erode. Now let's check the output. You can just observe. Okay, I think we are getting some error. Okay, see, here the error is that first you need to define this kernel, right? So let's suppose here I'm taking kernel equal to, and let's import numpy as well, because with the help of numpy I'll do this one, and I'm analyzing this one as np. So np dot once, here I'm making one images, right? And the shape I want to take it like 2 cross 2. Let's suppose here I'm taking 2 comma 2, and then the data type, like data type equal to np dot u sorry uint it. You can take any bit, right? So let me check it again. Yeah, so everything is fine. Now here instead of this I'll pass kernel. Now run again and let's see the output. Yeah, now you can see it is working, right? So see, but here you can see, as I told you, what is this erosion. There are two methods, right? One is the erosion and one is the dilation. First let's apply the dilation, then I'll show you the output between the erosion and, right? So erosion. Now the next one is the dilation. So here I'm taking dilate equal to cv2 dot dilate, and here also I'll just apply this on the thresholded value. And next one will be the kernel, sorry, cv2 dot kernel, and third argument will be here iterations. Here let's try with one only, right? And just display these images as well, so I'm sure, right? So this one will be the dilate, and then again dilate. Yeah, so let's run this one. Yeah, now you can clearly observe the difference between these two output, right? So this is your erosion, this is the output of erosion, and this is the output of dilation. See, in erosion you can see there are some more gap between the object, but in dilations you can see this gap, or you can say it's very less as compared to this erosions. Why? Because as I already explained you, in erosion, it will, what it will do? It will extract some pixels from the images, but in dilations, it will add some pixels to the images, right? That's why you are getting this output, right? So now do one thing. Right now we are not getting the clear output. So instead of one time, let's make this iterations 3 times so that we can see the output more clearly. Yeah, now you can see if I apply 3 times in this images, now you are not able to see the holes, because see, in dilations what we are doing, we are just filling the gap, right, between the two objects. Now here you can see, now there is no, and in this dilations we can, erosion, sorry, we can see now this gap is more as compared to previous one. Why? Because we have applied 3 times erosions on the input images, right? So this is the like purpose of applying erosions and dilation. This, see, this is one of the most important concepts also, right? Let's take some images and just apply these erosions and dilations, and you can clearly understand, and just change, vary these iterations as well. Let's see the output after iterating 1 time, or just observe the output after iterating 2 times or 3 times, 4 times, right? For better results you need to increase these iterations. Okay, so hope all of you understand about this erosions and dilation, that is morphology, right? So in the next class sessions, we will continue with the image processing and computer vision. So till now, bye everyone. Thank you so much.